Hi, I thought I would show how to edit a Vectric V-Carve Pro and Aspire post-processor to correct a few things and make it work better for WinCNC. You can see the different sections here. I'll go over it. This one's just the name and tells you basically what it is. Here's the history, who changed things, who wrote things in it. This is the name of the post-processor. This is the extension that goes on the end of the files that the post-processor generates. It works in inches. The units are inches. The line termination characters are 13 and 10. That means carriage return in the line feed. That means at the end of each line that it outputs, it will do a carriage return in a line feed. Lines number that it starts at on a file is 5 in this case, and it will increment 5. I will change that to 1 and 1. That way it starts at line number 1 and it increments 1, 2, 3, 4. It adds 1 at a time to the increment. These are the format of the variables, and you'd almost need the manual to go over to understand these. I can tell you that the A in this case means that it will always output this anytime that it's called. Like spindle speed will always output, even though it has not changed, it would always output if it were called. In here, the feed rate will only output if it were changed. The number here means basically you're concerned with this number, how many decimal places after the whole number, after the integer, how many decimal places it carries out for, in this case it's the X, Y, and Z position here that it's saying that we'll do 3 decimal places. In other words, it would be like if it were 1.234, it would show 1.234, but if it were 1.2345, it would truncate it to 1.234. It shows here that our arcs will be in incremental mode instead of absolute. In other words, this is how far it is away from the current point instead of how far it is away from absolute 0. Home positions, it's all here. These are just how they are formatted. It really is very important as to how the things are output in the file. Here's the header. It would start out, in this case, it's going to show the file name, and it's going to say that it's in G90 mode, which is absolute. You have absolute and relative or incremental mode, and we always work in absolute mode when we're doing these. It would shut off the spindle, raise Z all the way to the top, output the tool name here. Then it would call the tool. It would say T and the tool number. Say you called tool 3, it would say T3, and then it would tell you that it was getting tool number 3, which seems sort of redundant to do that twice. Here it's setting the spindle speed. The S by itself does the spindle speed. M3 turns the spindle on in most cases with WinCNC, spindle or router, if they're wired to do so. That's also with the spindle speed. If your machine does not have spindle speed, then this is pretty much ignored. Then it's saying to rapid, which G00 is a rapid move. That means you're moving above your material. It means rapid to the X home position and Y home position that you have stored in your V-Carve Pro or Aspire file. Then it's saying raise to the top and go on with the file. Now this is the tool change section. It's almost the same. It's nearly identical to up here. It's a little bit different, but it does the same thing. It's calling for the tool change, sets the spindle speed, turns the spindle on, raises to the top, rapids to the home position for X, Y, and this time it rapids to the home position in Z. Here it's doing the begin rapid move, so when it does that, it's always in this case going to set it to G90 mode again, which I think is another redundant thing. It doesn't really need to do that. We'll correct all that here in a minute. And it's rapiding to the X, Y, Z position that it should be going to. First feed move, it sets a G01 and moves to the XYZ position at the feed rate specified here. We're going to change this. We're not going to leave the feed rate on this line, because the problem is normally your X and Y have the same feed rate, but your Z more than likely will have a slower feed rate. Say for example you were cutting at 400 inches per minute on X and Y, but your Z, you have a Z plunge rate set at say 60 inches per minute. With this on the end of the line, if Z has the capability of reaching that 400 inches per minute that you have set in the file, when you put this F on here, it's going to set Z to the same speed. So then you would have X, Y, Z, and then F400, say. And Z would no longer be running at 60 inches per minute as you called for in your file. It would then be running at, say, 400, whatever your file was calling for the X and Y. So we're going to do away with that way of doing things here in a minute. Make this file work better. Make it, the post-processor, work better. Here is the normal feed moves. This is the feed moves that will be output after the first feed move. What we're going to do is, after we correct this, we won't need this first feed move anymore. So this will be our only G1 move. So we need to put a G01 at the beginning of this line. That way it will know that it's a G01, because this will no longer be here. We do not need a first feed move. After we correct the feed speeds, put them up in the headers and the tool change. Same thing for arc moves. This is a G2 first clockwise G2 move. It has an X, Y, I, and a J, and a feed move. We do not need this, so we will correct this and set it. The feed rate, remember, is going to be up the top, so we won't need this anymore, and we will use this line. And I'll capitalize that G, try to keep everything as close to the same as possible. And the same for a counterclockwise move. This will go away, and this will be the only one for the counterclockwise move. So then we've got our footer, and the footer, this G90 goes away. We don't need the G90 in every one of these. What it would be is these G90s would appear all over your tap file. They don't hurt anything, but it makes the file very hard to read if you had to read the file. Then it's turning off the spindle. It's raising Z to the Z home height. Now personally, I think this probably should be moved up above the M5. So I'm going to cut this away. And this is how easy it is to change a file, change a post-processor. And what that's going to do is it's going to raise it up. While the spindle's still running, it's going to raise it up out of the material. Then it's going to turn the spindle off. The reason I'm doing that is if you stop it in the material, you could burn your material or whatever with your tool. So it's best to raise up out of the material, then turn the spindle off. Then they're rapiding to the X0, Y0, which is probably okay, but if you had a clamp on the table, you might not want to go rapiding from wherever it's at. So I would recommend taking this G53Z0, which means raise all the way to the top, and placing it after you shut the spindle off, raise all the way to the top, then rapid to your X0, Y0, or wherever you wanted to move to. So now I'm going back up here and I'm going to start editing the file a little. So the first thing that we see there is the file name. Might want to move up here. Let's see, do we want to leave this? Yeah, we'll leave this the same. You could change this though so that it doesn't get mixed up with the one that you have. So I'll put WinCNC generic ATC arcs. What that means is this is pretty much going to work with any WinCNC there is. It may need to be altered a little bit later to turn on a vacuum or something like that, but otherwise these commands are pretty much just standard for WinCNC. So we're going to start in the header. We're going to leave that file name there. We're going to leave it in G90 mode. I'm going to delete this because all that would do is add an empty line there. And that makes it okay for reading, but it also leaves big spaces sometimes in your code. Leave the M5, turn the spindle off. I'll leave the G53Z0. I'm going to delete this line number. Now what we're going to do here is I'm going to copy this because it's putting the tool name, and then it's calling the tool and telling you that it's calling that tool number. Well, what I like to do is to put the tool name there and say I'm getting tool and the tool name. That way, if I'm getting a 1/4 inch tool, I'm saying T and say it's T3, and by the way, where this T inside the square bracket is, that's actually going to be replaced in your file with a number of the tool that's being called. So it would read something like T3 get tool and say 1/4 inch end mill if that were the tool name. Okay, then the next line is an empty space again, and I'm going to delete that one. And so this S is setting the spindle speed, and that is a good thing. We want to call our spindle speed if we have a spindle on the machine that we can set the speed of. We definitely want to call that out. If not, I think WinCNC is just going to ignore it. Then we turn the spindle on, which is correct. That's the right way of doing things. Now I'm going to copy this empty line here, and I'm going to paste it back in here one more time. And what I'm going to do is, remember when I said below that I need to set the feed rates up in the headers, up in the header and in the tool change section. So I want to go, I'm going to hit cap locks, I'm going to go F square bracket FC. That means feed rate for cutting, XY. And what I did there was I set a feed rate for X and Y at the feed rate set in Aspire or V-Carve for the XY tools. So now I'm going to do this for Z, and the thing is about Z is you can't use the FC because that is the feed rate set for X and Y, but there is one for Z called FP, plunge. So I'll do that and I'll go Z. So it's going to say the feed rate for XY was 400, it would say F. This is how your file would look. It would have an F 400 XY. And then when it got to Z, if Z were set at 60 in your file, in your Aspire, it would say F60Z. So we've just set feed rates for X and Y and a different feed rate for Z. So now it's set to rapid. G0 move is a rapid move to the X home, Y home. It's already in the air. because we did this tool change and that, so it should be in the air. We do not need this, I think, so I will delete that, and we don't need an empty line after it, so I'll delete that. Now we come to the tool change, and the tool change is very similar to the header, except it doesn't quite need everything that the header has. And one more thing that I think I'm going to add down here is I'm going to copy another empty space here, and I'll just copy this one here and paste it here. And I want to do a rapid to Z home. And that way it rapids down to the home position of Z. Say you had it a ½ inch above your material. After it's rapided to the XY position, you'll want it to move down at a rapid to the Z home. So now we're down into the tool change section, and so we do want to do we want to shut the spindle off. We want to raise Z all the way to the top. We'll delete this X space. We're going to do the same thing with our tool name. We're going to copy that and paste it here. We're going to take this out so that it's saying it's getting that tool name. And by the way, up here I forgot to do it, but I need to delete this one. Since I've already got it getting the tool, say 1/4 inch end mill here, I don't need it to say 1/4 inch end mill up here, so I delete that away, and now I'll do the same thing down here. Make sure that when you do any of these that you have your quotation marks on each end. That's very important. I once in a while will forget to do that, and I'll get an error when I try to run my post-processor. Also, before you start using any of these, verify that they are the correct ones to use by looking at the post-processor manual. This 91 here is an opening square bracket, and WinCNC recognizes that as a comment. Anything inside of square brackets is considered a comment to WinCNC. So it's saying square bracket, get tool, say 1/4 inch, and a closing square bracket. So now we've got that, we've got our spindle speed, and you can leave these comments here if you want to. You could actually take them out if you wanted to. So that's really up to your preference. And now the next line turns the spindle on. The M3 turns the spindle on. I'm going to delete a couple of lines here to get it crunched together. Next thing I'm going to do is go up here and copy all of this, and I'm going to come down here after my M3. I don't need that G53 right there again because it's already raised up to absolute Z0 there up here. So I'm going to paste this. I need to go here, and that is my tool change part. So now I'll shut my spindle off, raise up, I'll change my tool, I will set the spindle speed, turn my spindle on, set my feed rates for X, Y, and Z. I will rapid to my X home, Y home, then I will rapid to my Z home. So now our header and our tool change sections are correct. Okay, now we move down to our begin rapid move. You don't need this G90 here. You're already in absolute mode. We set that in the header section up here. So we'll delete any of those others that we see. This looks correct. We're going to rapid to X, Y, and Z. Okay, now we move down to the first feed move. Well, the thing is, we don't need this first feed move anymore. Every feed move is going to be exactly the same. If you were doing a post-processor and you had to add this feed rate to the end of the first feed move, then you would have to have that first feed move line. But since all of them are going to be the same because we put our feed rates up here, we do not need this section. So I'm going to delete that entire section right there out of the post-processor. Now we have a rapid move, then we have a feed move. We begin a rapid move, we begin a feed move. So now it will only output feed moves in this manner right here. Also, since we've already had our feed rate set up there, G2s are just clockwise arcs, and clockwise arcs are just feed moves. So the feed rate would be set up there above, as I showed a while ago. So I do not need this section either. And by the way, you see I'm getting rid of another G90 there. We do not need those because we set it up there initially. Do not need it. And now we have a begin clockwise arc. So now we've got our G2, XY, and IJ. That will work fine. Now we come down to our counterclockwise move. Ditto. I mean, it's exactly the same. It has this feed move on the end of it, feed rate set on the end of it. We do not need that. We set our feed rate up above, so this section needs to come out. We don't even need this section at all. There is no first counterclockwise arc. There's just a counterclockwise arc. They're all put out exactly the same, so I can delete this entire section of code. And now I've got a G3, X move, Y move, and an incremental IJ right there. So those are all correct. So now I'm going to add a new section, and this I saw on a forum, and it was put there by Brian from Vectric. And I believe it should be added here. This is for a file that has the same tool number, but maybe different feed rates. And the plus is telling it that this is a Vectric comment. In other words, Vectric ignores this. So now I need a begin, and I say new underscore segment, and I'll hit enter, and I'll turn my cap locks back off. No, I'll leave it on. And now I need one of those empty spaces, which I don't have, but I'll just copy a line and paste it in there a few times. Okay, and I'll make this one, set the spindle speed. And actually, I'll just go up here and copy my feed rates again. Bring them down here to my new segment. Now I've got my new segment, I've got yeah, I think that's what I need. So what this is going to do is, if someone would want to change the feed rate in the middle of a file, and I guess for some shapes you may want to do that with using the same tool, it would allow it. Also, a spindle speed change. So if your spindle needed to spin faster or something like that, it could do that. Now we'll go down to footer, which is the final thing in the file. We'll have a look at it, and when this one was done, there was a G90 added at the footer. Do not need that. G90 is set up at the top. Do not need one down here. So what we're going to do here is well, I mean, that would work. It's going to raise up to Z home height. It's going to turn off the spindle. It's going to rapid on up to the highest Z possible, the Z home, absolute home position. And then it's going to rapid to the absolute X0, Y0 position that is set in WinCNC. And that's how I would edit a post-processor for Aspire or V-Carve Pro for WinCNC. Now, one thing that I might want to add here is that I changed this. Oops, caps again. And added date. And say that I did more, but we'll call it quits at that. So that is how I would edit a post processor for the V-Carve Pro or Aspire.